Students, again I am going to explain some left portion from metals and non-metal. The topics which I am discussing here, that is meant for class 10 students. Here you see already in this chapter I have given 3 videos. Now I am going to make the 4th videos, and some important topics I have selected here. Here you see one question is there, or you have to express the electron dot structure structures of sodium, chlorine, oxygen, and magnesium. I hope in book only sodium and magnesiums are given, but here I have selected little bit more. Here, dear friends, you see for sodium, you know atomic number of sodium is how much? Atomic number of sodium is 11. That means there are 11 electrons in sodium atom. Now these electrons are distributed in the different cells around the nucleus in the atom of sodium, as I am showing you. Here you see this is the nucleus where neutron and proton you are keeping. Here you are keeping neutron and proton in the nucleus. Neutron and proton. Now, in the first cell or first energy level, there are 2 electrons. In the second energy level, you are having, or there are 8 electrons. First of all, 4 electrons you write, and then you make the pairs. Here you see 8 electrons you are getting in the second orbit or second cell. And in the third cell, what happens? Do you understand? Already you got, in the case of sodium, 2 electrons. Here it is sodium, so I am writing Na. 2 electrons in the first orbit or first cell, 8 electrons in the second cell, and remaining 1 electron, because atomic number is 11. Atomic number of sodium is 11, so number of protons will be 11, number of electrons will be 11. Here we are talking about electrons, so left 1 electron. Where it will go? Here we are writing in the outermost cell. Here you can write anywhere. Now, so it is the atomic structure. Now you write here sodium, and last valence electron is what? 1. So you have to mention here like that. This is the electron dot structure of sodium. Like that you have to write. Now here electron dot structure of sodium you have written. This was the first one, and second one you see chlorine. How can you write chlorine? Electron dot structure of chlorine. How can you write? You see, chlorine has atomic number 17. That means you have to divide the, or you have to distribute the electrons in the different cells around the nucleus of chlorine. So you see, first you write here nucleus, that is neutron and proton. I don't mention how many are there. Here you see, in the first cell you are getting 2 electrons. In the second cell or energy level you are getting 8 electrons. You know that in the third orbit or third cell, how many electrons will be there? Here you see, chlorine is there. So chlorine atomic number, you know how much is the electronic number? Electronic number or atomic number, 17 is the atomic number. So electronic configuration will be 2, 8 and 7. These 7 electrons will go where? In the last orbit. Here you see, firstly you write 1 electron around. Again we are repeating. So 7 electrons you got here. That means here in the last orbit, here I am writing the electrons, and here 2 electrons, 2 electrons, 2 electrons, and here 1 electrons. All together we are supposed to mention in the last cell only the valence electron. So this is the electron structure, electron dot structure of chlorine. Now what is left? Oxygen is there and magnesium is there. You see, electron dot structure of, here you see number 1, number 2, and electron dot structure of oxygen we are talking. Here you see, in the case of oxygen, what is the atomic number? Only 6. I hope you see what is the atomic number of oxygen. 8 will be there. I think it is 8. So here you see, in the case of oxygen, nucleus, neutron and proton, and first orbit there will be 2 electrons, and remaining 6 electrons will be in the last. Here what happened? 2 and 6. So 8 electrons. Atomic number is 8. So we are writing what? 6 electrons in the last. First orbit, first cell around the nucleus, 2 electrons are there. In the second cell, 1 electron is here. So 4 electrons has gone. Now you repeat 1. Now what remains? Do you understand? 2 to 4 to 6 electrons already came. So this is oxygen. Electronic configuration of oxygen is 2, 6. So I am writing here oxygen. Here ultimately you are writing here what? O you are writing, and on O there will be only the valence electrons. So here I am writing 2 electrons, and the rest 6 electrons, 4 electrons, 4 to 6 electrons you are getting. So in this way, this is the electron dot structure of oxygen. This is the electron dot structure of sodium, electron dot structure of chlorine, and this is the electron dot structure of oxygen. This O for oxygen. Now what is left now, dear friends? Now it is magnesium. You see, in the case of magnesium, what happens? Magnesium, atomic number of magnesium is 12. That means what happens? In the case of magnesium, you have to write, distribute the electrons 2, 8 and 2. That means here you see in the nucleus you are getting neutron and proton. Neutron and proton. And around it, the first cell contains 2 electrons. The second cell means what? Energy level will contain 8 electrons. Now 8 to 10 has gone already. Now what is left? In the last cell there are 2 electrons. 2 electrons are there. You can write like that. Magnesium you write like that, and 2 electrons you write here. So this is the electron dot structure of magnesium. In this way, electron dot structure for all the 4 elements I have written. In the examination, it is not sure that only these 4 electrons will element will come. Some more element may come, and if you are knowing atomic number of the elements, you can easily draw their electron dot structure. Dear friends, now I am going to rub it down. After that, we are going to show the formation of sodium chloride. In the previous video also I have shown you the formation of sodium chloride. I hope it will be better to repeat once again. Dear friends, whenever the compound is formed between the metal and non-metal, then metal has always a tendency to lose the electron, and non-metal has tendency to gain electrons to form the negative ion. So metal forms the positive ion after losing 1, 2, 3 like that electrons, or non-metal by gaining the electrons 1, 2, 3 like that, they form the negative ions. And between the positive ion and negative ion there is a force of attraction which bind them to form a compound, and that compound is called what? Ionic compound. Anyway, ionic compound separately I will discuss, but here I am showing the formation of some compounds. Here you see, show the formation of sodium chloride, sodium oxide, magnesium and magnesium oxide and magnesium chloride also. Magnesium chloride also. Here you see, first of all we are talking about the formation of sodium chloride. Here you see, number 1 we are talking formation of what process is there? By transfer of electron, by transfer of electrons. Here you see, formation of sodium chloride we are discussing. Sodium, you know, sodium is a metal and its electronic configuration is 281. That means 1 electron is there. Valence electron we are talking here. On the symbol of atom, what you are putting, that is what? Valence electron. Now, sodium is a metal and has only one electron, so it will lose one electron and form positive ion. Whenever electron is lost, that means what? One electron has been lost. So, here one positive. If two electrons could have been lost, then there will be two positive. Three electrons could be lost, then there would be three positive, like that. Here you see chlorine. In the case of chlorine, this is what 281 is electronic configuration. Now in the case of chlorine, what happens, do you understand? Chlorine has electronic configuration 287 because atomic number is 7. So here what happens, do you understand? 7 electron will be with electron dot. Here you see 2, 2, 4, 2, 6 and 1 electron is here. Now dear friends, it will gain, here is 1 electron, it is lost. Here it will gain 1 electron. Why 1 electron? If it is gaining 1 electron, then here is 7 electron and it will be 8. So 8 means what? It will be stable as by getting the electronic configuration of its nearest inert element. Now in this way electron is gained. So whenever electron is gained, it forms what? Positive ion. Negative ion. Gaining electron means what? Negative ion. Here you see, this is the negative ion. And between the positive and negative, there will be attraction. So, dear friends, we are concluding like that. Combining individually, I have shown you how it happens. Here you see, I am writing like that. Na, 1 positive, and here chlorine 2, only 1 electron is there. So transfer of electron takes place from where? Sodium to chlorine. Here what happens? After transferring, here it was having 281. Here it has 287. So 1 electron was short, 1 electron was more. Now what happens? Do you understand? Sodium positive by losing the electron and chlorine by gaining the electrons. What happens? Do you understand? By gaining the electron, it becomes -1. Between negative and positive, there is attraction. As a result, one compound is formed, that is NaCl. It is NaCl. And this compound will be called what? Ionic compound, because the compound formed by the meeting or combination of ions, that is called what? Ionic compound. Sometimes question may be arised or may be asked, what are the ions present in the sodium chloride? Then you can write sodium positive ions and chlorine, or you can write ions present in sodium chloride NaCl are Na positive and chlorine negative. Positive ions are called cation and negative ions are called anion. In this way you have seen how the, suppose you are not going to write these all, at least you write the last one, then also it is enough. Now second case, I hope you understood. I am going to rub it to get some space. Dear friends, now I am showing the formation of sodium oxide. Sodium oxide. Here you see, in the case of sodium oxide, what happens? There are two atoms of sodium. Here I am writing side by side, Na. Each sodium atom has the electronic configuration 281 because atomic number of sodium is 11. Here also same thing happens, 281. Now the last electron is called valence electron, which will be written here, which will be mentioned here. Now dear friends, along with sodium, now oxygen is involved. Here you see O for oxygen. Atomic number of oxygen you know, that is 8. How can you write? You can write like that. Electronic configuration you can mention like that, 2 and 6. Here distribute the electrons in the outermost orbit. Outermost shell, that is 6. How can you mention? 2, 2, 4 and 5 and 6. Here dear friends, 2 electrons are short because oxygen needs 8 electrons in the outermost orbit, but here only 6 electrons are there. Why 8? Because gaining the 8 electrons in the outermost orbit, an atom get the electronic configuration of its nearest inert element and it becomes stable. So what happens? One electron will come from sodium. One electron transfer from sodium, first sodium, and one electron transferred from second sodium. As a result, what happens? Do you understand? Sodium, I am writing like that. Here I write 2 because 2 atoms are there, so I have mentioned here 2. Now for each sodium what happens? For each sodium in the outermost orbit, there will be one positive because one electron is lost. So it became what? One positive. Here this is also lost, so it became one positive. And why 2 I have mentioned? Because there are 2 sodium atom. If here could be 3, then I was supposed to write 3. Now electronic configuration of sodium will be what? Here 2, 8. This is the electronic configuration, no need of writing. Now here you see, for sodium, while oxygen, what happens? Already one electron from here, one electron from this sodium. So all together oxygen has now 8 electrons. So you mention 8 electrons. You tell it becomes what? Do you understand? As it got 2 electrons, so it became 2 negative. 2 negative. And between the, you see 2 into 1 positive means 2 positive, and this is 2 negative. So how much you are getting the positive charge, same will be the negative charge also, and there will be the force of attraction between them. So they combine or they form what? Or you can write Na2O because 2 atoms are there. In this way you are forming what? Or formation of sodium oxide by transfer of electrons. Dear friends, what are the ions present here? So you can write ions present in Na2O are Na positive and O, Na positive and O negative. Like that you are getting. Dear friends, now I have to show you the formation of magnesium oxide by transfer of electron. I hope you understood it up to here. I had to rub it. Here you see formation of magnesium oxide by transfer of electrons, MgO. One by one you see. How can you write MgO? You see, there are two types of atoms present in MgO. One is metal, that is magnesium. One is non-metal, that is oxygen. Metal has the tendency to lose electron and non-metal has the tendency to gain electrons. First of all, I am supposed to write their electronic configuration and we have to show the electron dot structure of both. Here you see magnesium is there. Atomic number of magnesium you know, that is 12. How can you write? 2, 8 and 2. You see 2, 8, 2 means what? In the first cell there will be 2 electrons. In the second cell there will be 8 electrons. In the third cell there will be 2 electrons. So in the last cell or 2 electrons, that is valence cell. In the valence cell I am writing 2 electrons. Now plus oxygen you see. In the case of oxygen, atomic number is 8. So electronic configuration will be 2 and 6. Oxygen needs 2 more electrons in the valence cell so that it will be stable. 8 electrons, whenever 8 electrons will be there in the outermost cell, then the atom becomes stable. So we mention the 6 electrons in the outermost orbit. Here you see 2 electrons like that, we are writing separately. Now what happens? From here 1 electron is transferred and from here also 1 electron is transferred. Now what happens? Do you understand? Magnesium is losing 2 electrons. So magnesium becomes 2 positive. Why 2 positive? Because it has lost electron. And chlorine, oxygen has done what? Oxygen has gained 2 electrons. So altogether 8 electrons have come here. And you see, as 2 electrons oxygen is gaining, so there will be 2 negative. Now between the positive and negative ions, there will be a great force of attraction and ionic compound will be formed. So, or you may write like that, MgO, like that, MgO, magnesium oxide. Dear friends, what are the ions present here? Ions present in magnesium oxide are Mg, that is cation, and oxygen 2 negative, like that you can write 2 negative. Dear friends, after that one more is left, that is magnesium chloride. Here you see formation of magnesium chloride. Of magnesium chloride. You see how it is formed. Here one atom of magnesium combines with 2 atoms of chlorine. Here you see magnesium. What is the atomic number? That is 12. How can you write? 2, 8, 2. 2 electrons you have to write like that. Now you see chlorine. How many? 2 chlorine atoms are there. So one you write here and one you write below. Each chlorine atom, you know, it has atomic number 70. So you can write 2, 8, 7. Here also 2, 8, 7. Dear friends, you see, each chlorine atoms will have 7 electrons, valence electron. Here also 6 and 1, 7. So, one electron from magnesium goes here to the first chlorine, and 1 goes towards the second chlorine atoms. Now what happens as a result? Here you see magnesium, it is losing the 2 electrons. 2 electrons have been lost. That is why it became what? 2 positive. Now each chlorine atom, there are 2 chlorine atoms, so I am writing 2. If there would be 3 chlorine atoms, then I was supposed to write here 3. So we are writing chlorine here, and around the chlorine we are putting 6 electron dot, 8 electron dot, and this is what? Negative. 1 negative. Now dear friends, 2 positive and 1 negative. So 2 into 1 negative means what? 1 negative. Now they will combine together to form what? Magnesium chloride. Now what are the ions present here? Ions present in magnesium chloride are. Here you see Mg 2 positive and chlorine 1 negative. So in this way I have taught electron dot structure of 2-3 atoms and formation of some compounds by transfer of electrons from metals to non-metals. Now you come to know what is ionic compound. Let me rub it. After that I will discuss. Dear friends, what are called ionic compounds? The compounds formed by transfer of electrons, electron or I am writing S also. If 1 electron, then simply electron, and 2 or more electrons, then electrons. So the compounds formed by transfer of electrons from metal to non-metal atoms, from metal to non-metal atom, metal to non-metal atoms are called ionic compounds. Other name is also there, ionic compounds or electrovalent compounds. Example, NaCl, you see example I am writing here, you see NaCl. NaCl, how it has been formed? This is positive ion, and chlorine is what? Negative ion, and between the positive ion and negative ion there is the formation of NaCl. So it is ionic compounds. You can take sodium oxide also, you have seen, magnesium oxide also you have seen, or magnesium chloride you have seen, etc. Suppose some compounds are given and you have to decide which are ionic compounds, then you search in a compound, if one is metal and other is non-metal, then surely it will be ionic compound. Here you see, this is metal, this is non-metal, metal, non-metal. So metal, non-metal, that is why all are ionic compounds. I have written the definition what is given in your book, but other definition may be also there. What will be the other definition of ionic compounds? The compounds formed by combination of positive and negative ions are called ionic compounds. That is also very good definition. Dear friends, after that I am going to discuss about the properties of ionic compound. Let me discuss, and after that only I will write. You see, most of the ionic compounds are solid. Why they are solid? There is a great force of attraction between the positive ions and negative ions, or you can write the force of attraction between the ions, positive ions and negative ions, keeps the compound very tight, and that is why ionic compounds are solid. So first property what I am telling you, ionic compounds are solid. Second I am telling you, ionic compounds have high melting point and boiling point. Why high melting point and boiling point I am telling you? You see, for example, sodium chloride. Here what happens, we understand actually the sodium positive and chlorine negative ion is there. So between the positive and negative ion there is a strong force of attraction. When you are heating it, when you are applying the heat energy on this compound, then heat energy does what? Do you understand? That heat energy breaks the bond between the, or breaks the force of attraction between sodium and chlorine ions. So here large amount of heat energy is applied. That is why ionic compound has high melting point and boiling point. After that you come to know ionic compounds are soluble in water but insoluble in organic solvent. Soluble in water means what? Whenever you are putting suppose salt, common salt, that is sodium chloride, when you are putting in water, easily it can dissolve in it. But same ionic compounds cannot dissolve in the organic solvent like kerosene, alcohol, etc. You take little amount of common salt and put in kerosene, it will remain as it is for the longer period, it will not dissolve. Now the fourth property of ionic compound is like that, ionic compounds are good conductor of electricity in the molten state or in the form of solution. These are the four properties, very important. So I am writing, dear friends, one by one. Properties of ionic compounds. Here you see one by one. Ionic compounds are solid. Found in the solid state also you can write, are found in the solid solid state. Second, ionic compounds have high melting point and boiling point. Have high melting point and boiling point, or high melting and melting point and boiling point. Again, the third, ionic compounds are good conductor of electricity in the molten state. Molten state means what? When it is in the paste form, in the liquid form, so in the molten state or in solution. Now, fourth point, you see what is the difference? Ionic compounds are soluble in water. Compounds are soluble in water, but insoluble in organic solvent like alcohol, kerosene, etc. Dear friends, in this way, what are the things I have taught? I have taught ionic compounds and their properties. Now, in the next video, I'll discuss about why the ionic compounds have high melting point and boiling point, why ionic compounds are good conductor of electricity, why ionic compounds are found in the solid state. I hope the video is a little bit longer. You see again and again, and you must subscribe, so whenever new video I am uploading, you will get the information first of all. Thank you.